Hello. Okay. S. Okay. It will return a list of a path, which is a list of moves towards goal. Okay. Good enough. Hello. Welcome back to Python Challenge for All. Yes, right. Last time we were almost finished the automatic solver for 8 puzzles. So next thing is, yes, what we did was explained the idea of search tree and the words, and also made the function solver given a board. It will automatically solve, find the path to the goal state. And if you look at the code, the idea is make a task list, which we call open list. And the initial value is only one path, has the initial state in it, and pop it and check if it is goal. If goal, it is done. Otherwise, put it in the done list, which is already done, and enumerate the possible next moves, which we will implement today, and then add the new state to path and call it new path and append it to the task list. Okay, that's the basic idea. So let me explain. This is the basic idea of breadth first search. Okay, breadth first search means if we start from the root, let's check the next possible moves horizontally. Check this one, and then check this one. And then if they are not the goal, check this one, this one, this one, this one, this. Also, next, after checking all these, check the next generations. So this is what we call breadth first search, very basic classic approach. So in 8 puzzle, it will be like this. So if check, yeah, the possible 3 moves, 1, 2, 3. So if this is not goal, check this, this, this. If these are all not goals, check this one, which is the next possible move. Then, yeah, here, this one is in the done list. So it will check only this one. And this has 3 children, 6, 7, 8. And then check the child of 4, which is 9, like this. And then go back to here, 10, 11, 12, 13, 14, 15. Likewise. So this will check horizontally all the possible states that are children of the ancestors, ancestors of the initial state. Okay, so to implement that, basic idea is prepare open list, which initially has start state as this, pop the first one, and then add the children of A, put A in the closed list or down list, and then pop the first element C and put its children GH at the end of down list, open list, put C in closed list, and pop the top element from E, and likewise doing so. So it will be, this is what we implemented last time, right? So here, make a list of open, paths, and pop the first one. This will pop the top one, and call it the last element in the path is the current state. If it is goal, return success. If not, put it in the done list, and then list up the next possible moves, and for each, try the new ones. Here, we have to check actually if new state stat is in down list, then maybe we will do nothing. Continue. Okay? Continue. Okay, sorry. Continue. Okay? Right. Else, no. I don't need is here. If new stat in down list, then continue. Else, put a long new path, which is path appended by new stat, and then put it in the end of the open list like this. So okay, today we're going to implement next moves. So next move, check what are the possible moves from the current state. So empty panel is next. When the empty panel is next to the current position, it's possible. So okay, so let's here maybe we can just define next moves given state. Okay, so first let's find out where the position index of the 0 empty state. Okay, this will print out the index of the empty panel. Okay, so and then maybe prepare an empty list, and then for say panel in range, we'll check from 0 to n by nn. Okay, 0 to 8 this time. Okay, 0 to 8. So if this panel is next to the empty panel, so maybe we can use this Manhattan distance function. Okay, mdist 0 pos panel. Okay, so panel is the panel index and the 0 pos. So if the distance between the current panel, the panel to check and the 0 pos empty panel is 1, then we will add that new stat is, maybe we will just check that stat copy. Okay, maybe we don't need list here because it's already a list. Okay, so copy stat and then exchange the panel and the empty panel. So new stat 0 pos, sorry, 0 pos. So this should be 0, right? No. This should be the old current state. So stat panel value, okay? And then new stat panel position should be 0. Okay? And then after this will make the new state, right? Like it would be like, okay, moving from here. Let's check if 1 by 1, and this is next to 1. So we will make this state and add it to the new stat list. Okay, so next stat list append new stat. Okay, this is good enough. And then after computing this loop will produce from 1 to say 3, 1 to 4 at most. Okay, but if because there is here too we have to check, right? Let's see, where shall we test. Uh, Maybe we have to test here. If mdist in 0, okay, this is good. Okay, then return next stat L. Okay, so this will produce the next possible moves. And then it will check, okay, one by one, if that is also already in the done list. If the new stat is not in the done list, okay? If it is in the done list, just forget about it. Otherwise, put the new stat after path and append it to new open list. Actually, this is all very simple, okay? Please copy carefully. Okay, so lastly, let's check that this will move. Call solve with S key and check the operations. So here we implemented the new function solver. So we will call it from the main update function here. Okay. So update function will check if, say, in this case, if we hit the S key, so maybe we will call Pyxel, just like this one, button down, pt and p, bottom p, Pyxel dot key s. Okay, so Pyxel key s will find out whether our S key is hit or not. Okay, in that case, maybe we will put the solution. So the board has the current position, current board position, right? So it will given to the solver, and solver will return a path which will print. Okay, let's just print solution to see if this will solve, say, very simple problems. Okay, so I think this is good enough. Let's check with a very simple problem, like 1, 2, 3, 4, 5, 6. First, let's see what happens to this one. Let's call it. Okay, so, and then hit S. Okay, done. Good. It's solved. Very good. So it seems it's working. Let's try a little more difficult problems. 0, 7, 8. Okay, S. Okay, it will return a list of moves leading to, list of a path, which is a list of moves toward goal. Okay, good enough. Okay, so check the operations. It seems fine. So maybe next time, can we just go on and implement show step function? Maybe we will do it next time. Okay, so next time we will just make other parts so that we can check that this solution actually solves more difficult problems. Okay, so please enjoy, make new problems and see if this solver can solve problems properly. Okay? Come back. Be sure to come back. See you next time. Bye bye.